we go. Okay, so MIDI basics. MIDI is just about communication. It's just so keyboards and drum machines and things can talk to each other. If you're just using a computer, you are going to be using MIDI, but you're probably really not aware of like what MIDI does in the outside world, and that's honestly, that's okay. You know, unless you're actually connecting keyboards up to computers and keyboards to each other, you're not really going to use MIDI in the traditional sense. You're really just going to use MIDI just to play notes on a keyboard. And the real main important part to think about with MIDI to remember is that it's not audio. MIDI is not audio. And this is a big misconception that people have. They think that if I connect up a controller keyboard like right here, they think that if I connect up a controller keyboard over here to a sound module, there's some kind of audio that's traveling through the cable here, but that's not the case. What's happening is the signal is traveling through this cable here is really just a MIDI signal. It's just some binary numbers, binary data that tells the sound module what to play. So the audio is actually coming from the sound module over here. And with MIDI, there's 3 ports. There's an in port, which receives the data. That's this I right here. There's an out port that transmits the data. That's this O right here. And there's a T through, which copies the MIDI data from the in port. So I connect up my controller keyboard, and I play some notes on my controller keyboard, and it goes into here, and it tells the sound module what to play, what notes to play, how loud to play them, stuff like that. And that's it. MIDI can get more complicated, but it doesn't have to be more complicated, if you know what I mean. So, what is up, Smalls? So I don't want anybody to think that MIDI is like this big, huge, mysterious black hole that you know it's going to take months and months to learn. It's not really. It's not something you have to really focus on and worry about too much, especially this in, out, and through. These ports, this is the hardware side of things, and it doesn't affect you unless you actually have hardware. And even if you have hardware, it kind of depends on what hardware you have, because a lot of this in, out, through this stuff is really just taken care of with one USB cable. MIDI was made in the early 1980s, like 1983, 1984, and at that time, everything was very different from now. Nowadays, everything can just go through a USB cable and we're good to go. So I don't want to get too hung up on this. I'd rather focus on Pro Tools stuff. Just a couple of other basics for MIDI. It's data that travels through MIDI cables. There's data that travels through MIDI cables. Basically, you've got musical data, note numbers, pitch, velocity, control change data, which is the knobs and faders, buttons, stuff like that. Then you also have program change data. Program change data allows you to change the instruments that are playing at a time. Then you got utility in the global information, which is the clock, sync, and sysx data. Sysx data is basically backup for some kind of device. So let's say you have a reverb from the 80s and you want to save the settings for that reverb unit. You can do that using sysx data. That's what sysx is for. Utility global clock sync is if I have like a drum machine and it's got a beat programmed into it, and I want to hit play on Pro Tools and I want it to play that drum machine at the same tempo, that's what the clock sync does. So if I have my tempo on Pro Tools set to 110, I can have that automatically, my drum machine will play at 110 as well. It'll play at the same tempo. And that's what the clock sync is, and that's part of the global utility section. But the main part for MIDI data is the musical section, this part right up here. So in here, it's got your different notes that you play on a keyboard. So if you play high notes, low notes, that kind of stuff, velocity, hit the key harder, softer. That usually translates into how loud or soft something is, but not always. Then you have control change data. If you've ever seen like a DJ setup where they've got like a DJ controller, or some keyboards have knobs and faders on them, for example. Here, let's just go take a look at this MIDI controller keyboard. So if we take a look at these, so for example, the Sakai right here. The Sakai here has, you can see it's got some knobs on it, it's got some buttons and these over here as well. Let's see, there we go, it's a better picture. So you see these knobs across the top, and you see these two wheels here on the left hand side. Well, these are what we call control change parameters. They send control change data, so I could turn a knob and I could adjust the cutoff on my filter, or I could adjust the decay or the attack on my envelope, stuff like that. And that's stuff we're going to learn about another time. But that's control change data, which is right over here, knobs and faders, and then buttons too, if you have like play, start, stop, all that stuff, fast forward, rewind. It kept telling me this action is invalid. Is the date pushed back for the assignment? Cozy, but I don't know what you're talking about. Actually, I don't know who you are. Hold on, who are you, Cozy Boy? Oh, there we go. Oh, Caden. Oh, okay. Yeah, sorry. No, you're good, man. Thank you for letting me know. I appreciate it. There you go. Cool. Where was I? Over here. Boom. All right, so MIDI Basics. One thing that is important to understand, whether you're using Pro Tools or not, is about MIDI channels. MIDI channels are lanes that carry MIDI data. Think of a highway. On a highway, you have lanes, and each lane has cars and trucks and stuff like that, and they're going to different places. Well, that's what MIDI channels are. There's 16 MIDI channels on one port. So basically, if you're using one keyboard, that keyboard can handle up to 16 different MIDI channels. And each MIDI channel can have an instrument. Now, an instrument, if we look over here on the right-hand side, an instrument, which is also called a program, is basically the sounds in a device. So it's like a piano or a bass, drum kit, strings, sound effects, stuff like that. Those are all instruments. So for example, if I have a drum kit, well, maybe I put that drum kit on MIDI channel 10. And so MIDI channel 10 is I'm going to be playing my drums on MIDI channel 10. Maybe MIDI channel 1 plays a piano. Maybe MIDI channel 2 plays a bass. Maybe MIDI channel 3 plays something, and so on and so on and so on. And that's how these work. So the data, I'll be playing notes for my bass or my piano or whatever, and that'll be on one channel, and the bass will be on another channel, the drums will be on another channel. And they don't cross. The data stays in the lane. So you can have 16 lanes for a keyboard, except for some really fancy keyboards. And then each lane, each keyboard channel can have one instrument on it at a time. So again, the basics. I'm going really fast because I really want to get into Pro Tools and show you how to do some stuff in Pro Tools. MIDI hardware, a device, is a sound module. This is something that makes sound. This is a piece of hardware. What we call a MIDI device is a piece of hardware. And so we've got in here, you got synthesizers, sound modules, samplers, drum machines. Synthesizers and sound modules are very similar. A synthesizer is something that generates the sound internally, and a sound module, usually they use samples to play back sound. They're not samplers, but they use samples. The difference of that is a sampler is something you can record your own sounds onto. We're going to be diving way deeper into this when we talk about synthesis and sound design. So I don't want to get too deep into it right now, but just know there's all sorts of different devices out there in the world. There's synthesizers, sound modules. Sound modules can be synthesizers as well, just there's no keyboard on a sound module. A sampler, which is something you can record your own sounds into and you can play them back. And then a drum machine is got drums. So, all right. So if we've got a keyboard controller and a MIDI cable, we can connect these up. You know what I should do actually? I should show you my setup at the studio. What I'll do maybe is I'll do one class from my studio in Brooklyn at my friend's place. I'll talk to him and see if I can't do one class in there. Maybe, probably not Wednesday, but maybe like next week or something like that. I can do one class from there, maybe next Tuesday or something. Which reminds me, I have to talk about next Tuesday. So a MIDI hardware. So we got a controller and we got modules 1, 2, and 3 in this kind of scenario. And this is called a daisy chain when you have multiple MIDI devices connected together. So the MIDI controller can have one cable going out, and each module can have set for different receive channels. So one cable will have 16 channels, and then each module can have a few of those channels. So we could have like module 1 could be 1, 2, 3, 4, module 2 could be channels 11 through 14, and module 3 could be channel 10. And what we can do is, we could talk more about this on Zoom after everything. I want to come back because this is like, I have a feeling that y'all are sitting there just going, huh? I can't see your faces. I can't tell what's going on over there. If you want to type in the chat and be like, Tony, I'm super confused. Or if you want to hold on to this until we get to Zoom, this might actually be better in Zoom now that I think about it, just because I feel like we need to talk about this rather than me just being like, here you go, here you go, here you go. So why don't we kind of come back to this part here. But the main takeaway from this is you can have multiple modules connected up together. The MIDI cable is this blue cable here, but look, each one of these has an audio audio output. The audio output goes into the mixer here. The audio is separate from the MIDI. Here, we just zoom in down here. The audio out is separate from the MIDI out. Okay, and that's really, really important because the audio is not the same as MIDI. MIDI is not audio, MIDI is not audio, MIDI is not audio. All right, devices. We can have multi-timbral devices or non-multi-timbral devices. This doesn't, it kind of affects software, not really so much, but basically a multi-timbral device can play multiple instruments. Think of like if you have a hardware like a studio, or you've been in a studio like a Yamaha Motif or a Korg Triton or a Korg like the M1 from the 80s, Roland Phantoms. These are all multi-timbral devices. They have drums and keyboards and basses and synthesizers, all the stuff, and you can play a bunch of them at the same time, usually up to 16. Non-multi-timbral is everything else. Non-multi-timbral is a device that you can only play the one thing at a time. So if it's a synthesizer, you can only play the synth. If it's a drum machine, it's just a drum machine. Usually, multi-timbral devices are very expensive, like, you know, $600 to $1,000. They could be cheaper though. Non-multi-timbral really depends. A lot of modern day synthesizers, analog synthesizers people have been making are getting cheaper and cheaper and cheaper, and that's because the technology has been around for a while now. And you know, when technology has been around for a while, it just gets cheaper. But some synthesizers can be $3,000 and only be monophonic and non-multi-timbral. So it's not like just because it's more expensive means that it is multi-timbral. It can be really expensive and be non-multi-timbral as well. That doesn't mean it's bad. It just means it's very focused on one thing. Now, multi-timbral has to do with the devices and how many instruments can be in each device. The instruments can then be broken down into monophonic and polyphonic. Monophonic is an instrument that can play only one sound at a time, like a synth, lead, or bass. No chords on a monophonic instrument. Polyphonic is an instrument that can play multiple sounds simultaneously, like pianos, organs, strings, brass. These things have chords. They can play chords. So monophonic is just one note at a time. Polyphonic can play chords. And you might be saying, well, Tony, wait, hold on a second. Isn't polyphonic just better? The answer is no, not at all. Because when you're playing synthesizer sounds and you're doing synth stuff, a lot of times you want to be playing monophonic. You don't need to be playing chords with stuff. And to make some really cool sounds, a lot of the stuff we listen to that's not pianos or strings, it's mostly monophonic. You'd be really surprised. I used to kind of think when I first got into everything, this is in the 90s, that, you know, oh, polyphonic is better because it's polyphonic, it's more. But more is not better with this. When you're paying for this stuff, you're paying for the sound quality, really. And how you play changes if it's monophonic versus polyphonic. So for example here, we got our device is the Yamaha Motif, which is a keyboard. Inside this keyboard, we can have multiple instruments. So this is multi-timbral. We got piano, bass, drums, strings, right? Now each one of these instruments here can be monophonic or polyphonic. So for example, the piano is polyphonic, the drums are polyphonic, and the strings are polyphonic. They're all polyphonic. But the bass is probably monophonic because you don't need your bass guitar or your bass synth to be playing chords, usually. Okay, so that's how this would all break down here. All right, this one here is important. This doesn't necessarily have to do with MIDI hardware. It has to do with just MIDI in general, and it's going to come back to us when we start talking about some other things later on. So let's just take a second to kind of ingest this here. Note on, note off. When you press a key on the keyboard, that is a note on message. It sends a note on message, and it sends two things: the note number and the velocity. Velocity is how hard I hit the note. If I play really hard, it's a higher velocity. If I play really soft, it's a softer velocity. Usually that translates into audio, audio. Usually it translates into how loud the sound is, but not always. So if it's on a piano, it might be how loud or how soft it is. But if it's on a synthesizer, it's probably not. You can assign it to different things. The note number is if we're playing a high note or a low note. When you release the key, it sends a note off message. Now, the note on message and the note off message, the note number should be the same. if the computer or software, keyboard, whatever, does not get the proper note off message, that note is going to play forever and ever and ever until you make it stop. That's called a hung note. So or a stuck note. Press down here, you can look. Let's go ahead and zoom in on this. So I press the note, it sends the note velocity, the note number and the velocity, and I release it, and it sends the note number and the velocity. Note on, note off. This is something I didn't actually learn until way, way later, and I wish I had known this earlier, because it would have explained a lot about some of the problems I was having when I was starting off. This just talks about the stuck note when a device never receives a note off number. It's just the note just keeps playing and playing and playing. All right, so like I said, we're going to go over that again in Zoom later on. I'm just going to go ahead. I'm going to pause this recording here for a second.